Assalamu alaikum warahmatullahi wabarakatuh. This is Muhammad Zaid, a math teacher. Now we are going to talk about exponential function. Let's start. For example, f of x equals 2 times 3 to the power of x. 2 here is a coefficient, 3 is the base, and x is an exponent. Then f of x is called exponential function because it has variable in the exponent, and the variable here is x. Look at the definition in the box. An exponential function, the form has the form f of x equals a b to the power of x, where a doesn't equal 0 because of a equals 0, all of these amounts will disappear. Then there is no exponential function of a equals 0 because 0 times anything equals 0. And b doesn't equal 1. If b equals 1, that means 1 to the power of x equals 1. Then also x here will disappear. And b must be bigger than 0. This b must be bigger than 0. Identifying an exponential function from the tables. This example will demonstrate how can I know if this function is exponential or not from the table, not from the equation as we saw in the past slide. Look at this data: 0, 4, 1, 12, 2, 36, 3, and 108. We're going to drop this data in this table, x and y. X is 0, 1, 2, 3. As you know, x represents the first coordinates 0, 1, 2, 3, and y 4, 12, 36, 108, and y represents the second coordinate 108, 4, 12, 36, 108. Look at the values of y. Every time we multiply by 3, 4 multiplied by 3 equals 12, 12 multiplied by 3 equals 36, 36 multiplied by 3 equals 108. Then each time in y we multiply by 3, or each number in y equal its preceding by 3, its preceding by 3, its preceding by 3. 12 equals 4 times 3, 36 equals 12 by 3, sorry, and 108 equals 36 by 3. And each number of x increased by 1 every time you add 1. 0 plus 1 equals 1, 1 plus 1 equals 2, 2 plus 1 equals 3. Then you add the same number in x every time. So if you see this view here, every time you multiply by the same number in y, every time you add the same number in x, that means this function is exponential. The exponential function from the tables, if y multiplied by the same number each time and x is multiplied by the same number added by the same number each time, that means this function is an exponential function. Tell whether each set of ordered pairs satisfies an exponential function. Explain your answer. Here is the set of data: -1, -64, 0, 0, and 164, 2, and 128. We are going to drop this data in the table, x and y. X represents the first coordinates and y represents the second coordinates. We notice here every time in x we add the same number. -1 plus 1 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 2. Then the x coordinate, the x, each time you add the same number, or each number on x equal its preceding plus 1. Each number equal its preceding plus 1. And I noticed here in y portion, y column, every time I add by the same number 62, not multiply by the same number, I added by the same number. -64 plus 64 is 0, 0 plus 64 is 64, 64 plus 64 is 128. So this view doesn't match the property of the exponential function. Exponential function that represented by table, y must be multiplied by the same number, not added to the same number by the same numbers. Then this table doesn't represent an exponential function. One more example: this set of data, this set of data, -2, 4, -1, 2, 0, 1, 1, 0.5, we're going to drop these data in the following table. X represents the first coordinates and Y represents the second coordinates of these data. We notice here each time in X we added y1. -2 is added y1 to be -1. -1 is added to 1 to be 0. 0 is added to 1 to be 1. And each time in X we add 1. And each time in Y we make what? We multiply by 0.5. 4 times 0.5 is 2. 2 multiplied 0.5 is 1. 1 multiplied 0.5 is 0.5. And each time we multiply by 0.5. Then X we add constant each time, and in Y we multiply by constant each time. That means this table represents exponential function. Graphing exponential function. For example, graph y equals 0.5 times 2 to the power of x. First of all, we have to make a table to find the values of x and y, which I use to graph this exponential function. First of all, we are going to start with number 0 in x, substitute x by 0, then y equals what? 2 to the power of 0 is 1. 1 times 0.5 equals 0.5. Then you choose any number before x, for example, -1, substitute x by -1, then 2 to the power of -1 is half. Half times 0.5 is 0.25 or quarter. Then you choose any two numbers after 0, for example 1, substitute x by 1, then 2 to the power of 1 is 2 multiplied by 0.5 is 1, and 2 substitute x by 2, 2 to the power of 2 is 4, 4 times 0.5 is 2. Then we made this table. X is -1, 0, 1, 2, and y is 0.25, 0.5, 1, and 2. And I'm going to locate this point here in this right graph. The first point, -1 and 0.5, -1 and 0.5, I think here. Yeah, 0 and 0.5, 0 and 0.5 will be here. 1 and 1, 1 and 1 will be here. 2 and 2, 2 and 2 will be here. So I'm going to join this point as you see here and extend in both sides, in both directions. Actually, here we have a boundary of this graph. What is the boundary of this graph? Boundary of this graph is x-axis. This curve cannot cut or touch x-axis. The x-axis here, we can name it by asymptote. What is the asymptote? The line that represents the boundary which the graph cannot cut it. Another example here, y equals -1/4 times 2 to the power of x. To graph this exponential function, we have to make a table as we said before. Start with 0 and write at least one number before 0 and at least two numbers after 0. Okay, then find the values of y. Then values of y will be -0.125, -0.25, -0.5, and -1. So I'm going to locate this point in the right graph. The first point, -1 and -0.125 will be here. The second point, 0 and -0.25, I think it will be here. Third point, 1 and -0.5, 1 and -0.5 will be here. Third point, last point, 2 and -1, 2 and -1 will be here. Then we are going to join them and extend as you see in this graph. We notice that the graph here is going down. Because of what? Because of this negative. This negative reflects the original graph across x-axis to make this a new graph. The negative here means reflect across x-axis. The original graph will be like this. It will be reflected across x-axis to be like this because of this negative. The negative here make the graph going down. And do not forget, the x-axis is the boundary of the graph or asymptote, as we mentioned before. The graph cannot touch or cut the x-axis. So our graph here going down because of negative, and the graph cannot touch x-axis because x-axis here is called asymptote or the boundary of the graph. Graph y equals 2 times 0.5 to the power of x. The difference here, b is less than 1 and more than 0. The previous graphs, b was more than 1, but here b, as we said, less than 1. Let's go to see what the graph will be. Number 1, we have to make the table and substitute x by -1, 0, 1, 2. The values of y will be 4, 2, 1, 0.5. So we're going to locate the points here, -1 and 4, -1 and 4, 0, 2, 0 and 2, 1, 1, 1 and 1, and 2, 0.5, 2, 0.5 be here. Then join them and extend this our graph. This our graph, as you see, changed because here we have a change in the equation. B here is less than 1 and bigger than 0, and the coefficient is positive. Then the graph will be like this. Graph y equals -2 times 0.5 to the power of x. The changes here, we have b less than 1 and bigger than 0, and the coefficient is negative. We are going to make the table first, as we mentioned before. X here is -1, 0, 1, 2, and y will be -4, -2, -1, and -0.5. Then we are going to locate these points here in the right graph. The first point, -1, -4, -1, -4 here. Then 0, -2, 0, -2 will be here. 1, -1, 1 and -1 will be here. And 2, -0.5, 2 and -0.5 will be here. Then I'm going to join this graph and extend, as you see in the coordinate plane. Now the graph here like this, because two reasons. The first reason, we have b here less than 1 and bigger than 0. The second reason, the coefficient is negative, and the negative here means the graph is reflected across x-axis. The graph was like this, okay, and it reflected across x-axis to be like this because of this negative. Now we finished the all cases of the graph, so we are going to summarize the whole case in the next slide. Let's go to the next slide to see the whole case of the exponential function graph. We are going to summarize the general shapes of the exponential function graphs. The first graph, if we have here b bigger than 1, if b bigger than 1 and the coefficient positive, the graph will be like this. If b bigger than 1 and the coefficient negative, then the graph will be like this, going down. Again, if b bigger than 1 and a positive, then the graph will be like this, going up. If the b bigger than 1 and a is negative, then the graph will go down to be like this. In the second case, if the b between 1 and 0, decimal or fraction between 1 and 0, less than 1 and bigger than 0, and a positive, the graph will be like this. Again, if b less than 1 and bigger than 0 and a is positive, the graph will be like this. And if the b between 1 and 0 and a negative, the graph will be like this. The whole cases of graphing exponential function. And this was last point of today's lesson. Thank you for listening. Good luck.